the empirical rule for normal distributions. A bell-shaped curve is called a normal distribution. So if we look at a curve like this, we say that it's distributed normally. Now, the mean of this distribution is the high point. So this is the mean. And the standard deviation occurs where it changes from bending down to bending up. So the standard deviation is about here. Now the symbols that we use for the mean, we tend to use the symbol mu, that is a population mean. For the standard deviation, we tend to use this symbol, sigma. But when we're computing standard deviation by hand, we tend to use S instead. And there's a small change. When we use S, we divide by n minus 1. When we use sigma, we divide by n. But when we're talking about these things from a theoretical perspective, we prefer to talk about the population standard deviation, sigma. So our rule states the following. If a data set is normally distributed, we expect about 68% of the data to lie within one standard deviation of the mean. And 95% of the data, and about 95% of the data, to lie within two standard deviations of the mean. And about 99.7% of the data to lie within three standard deviations of the mean. So this is the empirical rule, and we want to discuss the empirical rule for the following data set, the following example. A certain IQ test has scores that are normally distributed, very important, with a mean of 100 and a standard deviation of 15. So if we want to discuss the empirical rule, we're going to draw the curve. The mean is here, standard deviation is about there, excuse me, the mean is here, call it 0 for now. And there's the mean plus the standard deviation, and there's the mean minus the standard deviation. So up top, I guess I should have said mean plus standard deviation there. So we'll go ahead and we'll add that discussion. So starting with our mean of 0, mean plus standard deviation on the right, mean minus the standard deviation on the left. Within one standard deviation, we expect 68% of the data. Within two standard deviations, so again, let's draw another picture. So if this is the mean mu, and we're adding two standard deviation, mean plus two standard deviations, mean minus two standard deviations, this is supposed to be 95% of the data. And if we go to three standard deviations, all the way here to mean minus three standard deviations to mean plus three standard deviations, that's supposed to be 99.7% of the data. Now for this example, what do we have? For our example, we have a mean of 100 and a standard deviation of 15. So within one standard deviation, that would be 100 minus 15 to 100 plus 15. What we're saying is we expect about 68% of the data to lie between, what is that, 85 and 115? So that's telling us that 68% of the people will have IQ scores between 85 and 115. Now within two standard deviations, so again, mean is 100, standard deviation is 15, two standard deviations is 30. So if I go mean minus two standard deviations, that's 100 minus 30. Mean plus two standard deviations, that's 100 plus 30. So here we're getting 70, here we're getting 130. So that's within two standard deviations. So we expect about 95% of the population, or of the IQ scores. We expect about 95% of the data, of the IQ scores of the people, to be between 70 and 130. And to go to three standard deviations, mean minus three standard deviations would be 100 minus 3 times 15, which is 100 minus 45, which is 55. Mean plus 3 standard deviations is 100 plus 3 times 15, which is 100 plus 45, which is 145. We expect 99.7% of the IQ scores to be between those two numbers. .7% of the data, in this case, IQ scores, to be between 55 and 145. Note, data sets must be normally distributed to use the empirical rule. In general, we can use Chebyshev's rule that states at least 75% of the data, not approximately, but at least 75% of the data lies within 2 standard deviations of the mean. Chebyshev does not require bell-shaped curves. You do not have to be normal to use Chebyshev. Chebyshev says at least 75%. The empirical rule says about 95% are within 2 standard deviations. But that's not a contradiction. Certainly 95% is at least 75%. So that indeed does reflect the reality of being within 2 standard deviations of the mean. And that will conclude this lesson.